Hi, good evening. We're ready to start the session now. Just give me a quick yes if you can hear me, so we can start the session. Just give me a quick yes if you can hear me properly. If I'm audible, just write a yes, then we can start the session. Good evening, good evening, good evening. Yes, सोनी आज आप टाइम पे आए तो मैं लेट हो गया. Good evening, just a yes very quickly. All right, so I get a first yes from Purna and a lot of yeses. Wonderful, wonderful. So I think I'm audible. You can stop this and let's start with the session. All right, wonderful. So there's this quote written here. I think all of you have seen it before I appeared on the screen. Have you heard about it? Have you heard about Galileo? If you know about him, wonderful. If you haven't heard of him, then it's a cause for concern. Fine, you need to read better. You need to read a little more. Fine. I have put this quote here. This is one of my favorite quotes, favorite all-time quotations. Fine. I've put it here for a reason. अगर आप इसको देखेंगे, then you'll realize that this is about using your brain. Fine. बहुत सिंपल भाषा में बोलता है कि आपको भगवान ने दिमाग दिया है, उसका इस्तेमाल करो. किसी की भी बात अगर आपको सुननी भी है, तो भी अपना दिमाग का इस्तेमाल करके सुनो. Now this is very very relevant when it comes to a topic like this. I mean, I've done a lot of research on this topic on internet, and I mean that is full of junk, a lot of junk on this topic. This is a very simple, very beautiful, very very pretty topic. We'll give you 5 out of 5 marks in probably 3-4 minutes, but it's full of a lot of junk. Fine, just give me a moment. Just give me a moment. Just a moment. All right, so yeah. So I was saying that this is a beautiful quotation that I actually ask you to follow in your lives. Think before you act on any such thing. So today also in this session, I'm not going to give you. I'm not going to prescribe anything. I'll just kind of discuss a few things. If you like them, use them. If you do not like them, just think of it as a waste of 120 minutes, right? I'll tell you where it started from. I've heard of a lot of probably alternate ways that people used to do syllogisms. I haven't used any method to do syllogisms ever apart from Venn diagrams. So either I do it mentally without doing anything, if the question is very simple, all of you understand that it's at times possible, or just by doing Venn diagrams. Think about it. If you like it, use it. Otherwise, use whatever method you feel like. Fine. So I thought just I'll put it there. So let's start this thing today. Today again, I'll say there's a good news and a bad news. The bad news is that India could not force a win over the Aussies, so I'm not very happy about it. Let's make our day happy. Let's make it good by having a productive session here. Fine. So I'll remove myself from the screen here, and I'll just explain to you a few very very basic things about syllogism. What is syllogism? Fine. So all of you who are initiated onto the topic, just bear with me. I'll start with the basics so that nobody misses out on it. थोड़ा सा मैं बेसिक से स्टार्ट करूँगा, आप मेरे साथ बेयर कीजिएगा. देयर विल बी जूस फॉर एवरीबडी हियर, राइट? ओके, एक स्टेटमेंट लिखता हूँ यहाँ से, इसको देखिएगा. लेट्स से आई राइट अ स्टेटमेंट लाइक दिस. आई होप आई एम लेजिबल. ऑल ऑफ यू कैन रीड माई हैंड राइटिंग. ठीक है, एक स्टेटमेंट लिखा मैंने, ऑल अवर स्टूडेंट्स आर स्मार्ट. Fine, this is one statement. Let's say I'm giving you another statement here. All smart students would crack the exam. That is a second statement. Fine. So this is simple. This is statement 1 here, and this is statement 2 here. One statement says all of our students are smart. So I'm saying that all of you are smart. Statement 2 says all smart students would crack the exam. Fine. So these are the two statements. So what I'm trying to do is I'm trying to just explain to you in a very simple manner what syllogism is. If I club the two statements, what would it mean? If I club the two, I'm saying all of our students are smart, and then you know that all smart students would crack the exam. What it means is that all our students would, crack the exam. That is what it means, right? You don't believe me, I keep saying this time and again, you don't believe me. Now the logic also says that same thing. Fine. So this is the structure of syllogism, and it's just that three statements basically. So these two, 1 and 2, are called premise, premise. Do you not need it, but this is the basics of deductive logic, so I thought I'll tell you. This is called premise, and this one here is called conclusion. Premise at times is also called statement, that's used in your questions, but it's just this structure, 1, 2 and 3. So you club 1 and 2, and you get 3, and that's syllogism and nothing else. So you club 2 premises and you get a conclusion. Now you'll say that there are at times 3, 4, 5 statements as well. वो भी इसको जोड़ कर ही मिलते हैं. So when you club the two, all our students would crack the exam. So now this is the third statement. Now I can say all our students who crack the exam would be very successful in life. Fine. So that's a fourth statement. If I club all the statements, then it becomes all our students would be very successful in their lives. Fine. So you can continue the logic, but it's essentially a 3 statement structure. This is it. There is absolutely nothing else in it, and this is how it works. So that's the basic of deductive logic. You do not need to get further into it. Let's come to the point now. There are 4 types of statements when it comes to deductive logic. So I'll just discuss them very briefly with you. This is extremely important because with the kind of stuff that I've seen all over the internet, people are actually confused with a variety of statements that talk about so many things that actually do not come into the theory of syllogisms ever. Fine. There are just 4 basic type of statements in syllogisms. Fine. So whenever you come across a statement in a syllogism question, just think of it in terms of these 4 statements. I'll start here. So there are 2 broad categorizations. One is this universal and particular, and another would be affirmative and negative. When affirmative, all of you know is what? It's positive. Affirmative means positive. So affirmative statements would be positive statements. Negative you all know is negative. So this is negative statements. Universal and particular क्या होता है ये मैं आपको अभी बताता हूँ. इसमें आगे चलते हैं एक बार. Just look at this statement. This first statement, the most important one probably. All A are B. You have been using it all your life. All A are B. So it can be put in any form. All cats are dogs. Fine. All buses are trucks. You see all such kind of weird statements. But all of the form, all the statements are of the form all A are B. ये आपका सबसे ज़्यादा यूज होने वाला स्टेटमेंट है इसके अंदर, जो कि यूनिवर्सल अफर्मेटिव है. मैं इसको बराबर स्ट्रेस इसके लिए कर रहा हूँ बिकॉज यू नीड टू रिमेंबर दिस दैट दिस इज अ पॉजिटिव स्टेटमेंट. This is a positive statements. There are 4 statements, 2 are positive, 2 are negative. So this is one of the positive statements, all A are B. Let's move forward. This second statement would be universal negative. It is no A are B. ये आपका दूसरा statement है which is a universal negative. इसका मतलब है इसमें ऐसे statements आएंगे no trucks or buses, no cats and dogs and thing like that. Fine. The third one is particular affirmative. यहाँ पर अगर आपने देखा था ऊपर, if you look at this one, so this was universal. I was talking about all here. Fine. This is particular. This is a positive statement. Fine. Some A or B, but this is particular because I'm talking about some people or some entities. I'm not talking about all. Fine. So that's why this is particular affirmative. So these 2 are positive statements. If I'm talking about positive statements syllogisms, it's just two. All A or B and some A or B. उसके अलावा कोई भी और positive statement syllogisms की theory के अंदर नहीं होता है. Fine. Let's go to the fourth one. This one. This is particular negative. It says some A are not B. Now this is very obvious. I'm saying some A are not B. This is again some. Since this is some, so it's particular, this particular, and this is, since this is not, it is negative. So there are 2 negative statements, no A are B and some A are not B. Just you do not think that this is not useful. This is very, very important because when I use these terms like this is a negative statement, this is an affirmative statement, don't get confused. 2 negative statements are there, no A are B and some A are not B, just these 2. 2 positive statements are there, all A are B and some A are B. There are in all just 4 types of statements in the theory of syllogism, right? Let's move forward. Alright, so I am discussing the first statement now, all A are B, the most simple one. You can interpret it in 2 ways, fine. This is the first way. What is happening here? All of you know a bit about set theory, fine. So A is a set, this is A, fine, and B is a bigger set. So basically all A or B means that all the elements of A, this A, are contained within the elements of B. So A is basically a subset of B, simple. इसके अलावा इसका और कोई मतलब नहीं होता that A is a smaller set, B is a bigger set. इससे भी यही लगता है ना, all A are B, that A is smaller and B is bigger. So this is one interpretation of all A are B, and this is the diagram that you will keep drawing all the time when it comes to all A are B. The moment you see all A are B, you will draw this diagram. this is the minimum overlap diagram for all ARB. I am using this term here, some of you would be familiar, some of you would be not, but this is a minimum overlap diagram for all ARB, which is all important for this entire exercise. But this is not all, there is another one. If you look at this one, in this case A and B are equal. If you look at this one here, this is A as well as B. It means that A and B are exactly identical. So it means all the elements that are in A are also in B and vice versa. Fine. So this is another interpretation of all A or B. So the moment you see this, fine, A and B being equal, do not think that this cannot be all A or B. So many people have this confusion here that all A or B means just this. No, that's false. All A or B can mean this as well, this one. Fine. So this can also be all A or B. I'll explain it later in great detail, but just remember this. All A or B can be interpreted in two ways. This is one and this is two. Fine. For all practical purposes, when you start drawing it, when you start solving the questions, you will be using this one. So just remember this, but just keep this in mind, this second one. All right. Okay. Let me move forward. एक और चीज इसमें आप नहीं infer करेंगे, which is obvious from this second diagram here, this one, that there are some elements in set B that are not in set A. Fine. इसका मतलब ये दोनों बराबर हो सकते हैं. Just remember this. This is extremely critical. I have seen people getting confused over this. And just remember one more thing, that it is different from all B or A. I think all of you understand that if there are two interpretations of all A or B, this is one and this is two, this one would be identical for all B or A. Fine, this would remain the same. But when I have to draw all B or A, fine, this 1.1 here would become something like this. Fine, so the B becomes the smaller set and A would become the larger set. So this would be all B or A. Fine. So there is a difference between all A or B and all B or A. Just keep that in mind. Fine. So I think this is clear. This is our first statement, the most important one, all A or B. I am moving to the next one. Just keep this in mind. Just keep this in mind. All right. So this is the second one, no A or B. Now this is the simplest statement. If you look at this, this is the simplest statement. This is set A, this one here, and this is set B. These sets are disjoint. Disjoint sets क्या होते हैं? Disjoint sets are sets in which there are no common elements. Fine. So they are mutually exclusive. Fine. And how do we represent them? Something like this. So this cross here, just a minute. This cross here shows me or tells me when I'm doing a question that A and B are disjoint. It means that A and B cannot overlap. Just remember this. These are two sets A and B that do not overlap. So the moment you see no A or B, you have to draw something like this. This is A, fine, and this is B, and they do not overlap, and you will draw something like this. So it will tell you that A and B are disjoint sets in this case. Fine, this is the simplest. There is just one case, A and B do not overlap, and there is nothing else in this. Let's move forward. This would be same as no B and A, no B or A. Fine, you understand that. So जब A और B disjoint है इस तरीके से, so no A or B and no B or A would be the same thing. So if I have to draw no B or A, I'll draw this same thing again. Okay. The third thing, it is sometimes written as, if you look at this, just a moment, if you look at this is sometimes written as all A are not B. Fine. All A are not B की तरह भी इसको लिखा जाता है. Just remember this. कई लोगों को लगता है कि all A are not B का मतलब है that there are some A that are B and there are some A that are not B. Fine. How do you look at it? When you look at this all A, this thing, this all A. Fine. All A becomes an entity. So I am saying all A and B, they are disjoint. Fine. So all A are not B is same as no A or B. Remember this. You get confused in this thing. There are a lot of other things in which you get confused, but this is one of those issues in which a lot of students get confused. So just remember this. All A are not B is same as no A or B. Fine. I'm moving forward to the third statement now. Just kind of make sure that you get this in your head. This is extremely critical. Some A or B. Fine. Some A or B is again a problem statement for many. Fine. How do you draw it? Some A or B. So this is set A. Fine. When this is set A, some A or B means a partial overlap. So this is a partial overlap here. Some A or B. Fine. And the important thing here is that there is at least one element. There is at least one element that is both in set A and set B. So what is that region? This is the common region. So some A or B means that there is some overlap between two sets A and B, right? So this is the region that's shown there, and it cannot be empty. So just remember this when you're drawing some A or B. This is the region, this middle region here, there will never be empty. Fine, just remember this. And there are four interpretations of some A or B. but this is the one that you'll use most extensively. This is the one interpretation of, this is the, you know, the most important interpretation of sum A or B, which you'll be using every time and which you'll start doing a question with. Fine. So when you have to do a question, this is the first thing that you draw when you see a statement like some cats are dogs or some buses are trucks. Fine, just remember this, that's the interpretation, but it does not mean that this is the only interpretation. Fine, let me move forward and show you. Look at this now. If you look at this, just a moment. Guys, can I, Samir told me that you are asking कि आज मैं basics ही कराऊंगा क्या? यार, let me explain the basics. How else would I move forward? If I give you a tough question, you will struggle there. Give me 5 minutes, यार. When do I waste time telling my personal stories to you? Have I? Do I ever do that? Give me 5 minutes. Let me complete this. I'll move to the questions. If somebody has seen my videos on syllogisms earlier and you do not have a problem, then you might find it slightly repetitive, for the simple reason that there are just two extra concepts that I have discussed here. One is how to draw sum knot and solve questions there, and how to handle that either or thing. There is a confusion there. Fine. So there are just two extra things. So if you are very comfortable with what all have I done earlier, you can probably leave the stream. So I'm assuming there are a lot of people who want to learn it from the scratch. Fine. So it's your call, right? Okay. Let me move forward. Okay, so I was saying that this one is not the only interpretation of sum A or B. This is the basic diagram that you draw for sum A or B, and there are three more. Fine, look at this one. This is again that same thing. This is again extremely important. This shows that A and B are equal. Fine, A and B both are equal sets. But when I deduce from this that sum A or B, people get confused. ये तो बराबर है. How can this be sum A or B? Fine, ये भी होता है. Sum A or B just means that there is an overlap. So it can be a complete overlap as well. Fine. So this is also a possible case for sum A or B. Right. I'll move to the third one now. An important thing here to note would be that sum A or B does not mean that sum A or not B. जैसे आप अपने बातचीत की भाषा में नहीं बोलते हैं कि some of my classmates are smart. उसका मतलब क्या होता है? उसका मतलब होता है कि आप ये इन्फर करना चाहते हैं सम ऑफ द क्लासमेट्स आर नॉट स्मार्ट. यहाँ पर उसका ये मतलब नहीं होगा. इफ यू आर सेइंग सम ऑफ माई क्लासमेट्स आर स्मार्ट, what you are saying is that some of my classmates are definitely smart, I do not know about the rest. So it goes here as well. When you are saying sum A or B, it definitely does not mean that sum A or not B, right? Look at this third one now, this one. This is again sum A or B. It looks something like all B are A, but this is again an interpretation of sum A or B. So if you get this one, do not get confused. This can very well mean sum A or B. क्योंकि इसमें भी overlap तो हो ही रहा है ना, in this 3.3, and the fourth one would be this one. So this is again, if you look at this, now this is B is the larger set here and A is the smaller set, then there is again an overlap and there are four interpretations. So what I am trying to tell you is that sum A or B, this statement may mean these four things, this one, this one, this one and this one. What you need to ensure is that you realize that the most important one is this one. So we start doing all our questions with this one. But when you extend the diagram to check for negative statements or possibility cases, you will use these three as well. Fine, that's the important part here. I'll move forward. एक और चीज इसमें ध्यान रखिएगा, it is the same as sum A or A. So when you are saying sum A or B, it is same as saying sum B or A. There is absolutely no difference in this case. And I'll move to the last statement before I go on to the questions now. Again an important one, sum A or not B. It creates problems to students. Again a simple one, sum A or not B कैसे बनेगा ये? If you look at this part, sum A or not B means that there is some portion of A that is not a part of B. What is this portion here? This one. Fine. So that shows sum A or not B. If you look at this, it just means that there is at least one element in set A that is not a part of set B. And what's the region? It is this region, this region. So this region here, this highlighted region here, this region cannot be empty. But this is again not the only interpretation of sum A or not B. Sum A or not B can be done like this as well. Now you'll say that these are disjoint sets. Yes, these are disjoint sets. So this is a case of no A or B. But sum A or not B just means that there is at least one element in set A that is not in set B. So this also satisfies that condition. So this can be another interpretation for sum A or not B. Again, this is extremely critical. Don't blame me if you do not get it at a later stage and ask me, sir, ये क्यों हो रहा है? I'm not doing this theory for fun. This is important. This is just 10 minutes. I'll go to the question straight away. Even I do not like doing this. All right. Again, another important thing, you cannot infer from this that some A are B. So the way you cannot infer from some A are B that some A are not B, you cannot infer from some A are not B that some A are B. तो अगर मैं बोल रहा हूँ some of my classmates are not smart, it does not mean that I'm trying to imply that some of my classmates are smart. I'm just saying that I know about some people, they are not smart. I do not know about the rest. Just remember it like this. All right, and then this one. This is the last interpretation again. If I'm saying some A are not B, this is again a possible case. So A becomes a bigger set here and B a smaller set. In this case also see this region here. So this is all the elements of A that are not a part of B. So this is another interpretation. So some A are not B can again be shown in 3 ways. Fine. So I have shown you all the 4 statements and the ways in which they can be represented in the form of a Venn diagram. This is extremely important. If you do not get this theory, come back to it again, understand it. This comes in handy while dealing with questions very quickly. Fine. So this is the theory. One last thing is, इसको आप इससे कंफ्यूज मत कीजिएगा. सम बी आर नॉट ए इज डिफरेंट फ्रॉम सम ए आर नॉट बी. अगेन पीपल गेट कंफ्यूज बिटवीन द टू. फाइन. तो इसमें पैरेलल स्ट्रक्चर नहीं है. सम ए आर नॉट बी वुड बी डिफरेंट फ्रॉम सम बी आर नॉट ए. Fine. So this is it when it comes to theory. I'll go to the question now. Fine. This is what you are waiting for. So that's your question. So that's the question. I'm not giving you any time to solve it first because I want to show to you how do you proceed in questions like this. Fine. Just listen to it now. Look at the first statement. So that I'll just tell you the brief structure of all these questions. You will be given 2, 3, 4 statements. Fine. 1, 2, 3, 4. जैसे इसमें there are 4 statements that are given to you, and it will be followed by 4 or 3 or 2 conclusions, and you have to tell how many conclusions or which all conclusions follow from the given statements, right? And then you mark the answer here accordingly. So that's what the questions ask you to do. So the first step, what you do? Fine. You go to the statement straight away. Look at the statement. Some bikes are cars. Now remember that some A are B. How do you draw this? First thing would be I draw bikes here. So you draw a circle that shows bikes. So this is the element of bikes. Now some bikes are cars. Where do you draw cars? You draw cars like this. Some bikes are cars. You can see a partial overlap between bikes and cars. Everybody understands that how this is done. It's simple. Now go to statement 2. All ships are trains. Now this is bikes and cars here. Ships are not discussed. How do I draw ships? I do ships like this. Fine. So ships is separated from this one. Fine. If you look at this part, this is ships, this is separated because right now at this stage I do not know of any connection between bikes, cars and ships. Fine. I'll move forward. Look at statement 3 now. At least some buses are cars. Now this is again, I've been telling you that there is, so much redundancy in all these statements. This at least means nothing. Fine. And likewise, there are so many statements that, do not mean anything in syllogisms. So whenever you see an at least, just cancel it like that. So at least some buses are cars just means some buses are cars. Fine. Now you know where cars are. So I'm saying some buses are cars. This is cars in front of you. How do you draw it? You draw it like this. Okay. सबसे पहले तो okay. I have to just a minute. I skipped 2. 2 said all ships are trains. Fine. So ships is drawn here. How do I draw trains? I do trains like this. Fine. All ships are trains. So ships are contained within trains in this. This is simple now. Look at the third one. Some buses are cars. If you look at this third one, where are cars? This is cars here. Now if I have to show an overlap between buses and cars, the only thing that you need to take care of in this would be that you do not do an overlap with bikes here. Fine. So if you have to show an overlap between buses and cars, keep this bikes separate from it. This is called minimum overlap Venn diagram. Fine. You do not do anything here. Fine. All of you are busy in giving the answers. I am not even looking at it because I want to explain something to you. We'll do it in a jiffy. They'll just take 30 seconds. But the important part is this theory. Just understand it once and then you'll be good forever. Believe me. Fine. So if I have to draw this, some buses are cars here. How do I do it? I do it like this. So you look here, I have separated it from bikes. So there is no overlaps between bikes and buses because I want to keep this overlap minimum possible. This is minimum overlap diagram. Fine. So when it's an intersection between cars and buses, I'll just do this part and nothing else. Fine. Move forward and look at this last one now. No buses are ships. Fine. No buses are ships. This is buses here and this is ships. Now they are already not overlapping. What you do in a case like this is that you draw something like this. You draw something like this. What it does for you is that while manipulating to check for negative conclusions and probability, possibility questions, you know that buses and ships cannot overlap. Fine, just remember this. This is an important notation. This is important because this sign would tell you, look, if you think about it, even trains, this trains is separated from buses. Fine, if trains and buses are separated, how do you know that ships and buses and trains and buses, the status is different? You would know through this arrow. Fine, this arrow here tells you that whatever I do with this Venn diagram, I would never overlap buses and ships. That's the only purpose of this Venn diagram, this thing. Fine, so that's your minimum overlap Venn diagram. I have explained it extensively for this question because I wanted you to understand how to draw it properly. If you get it properly, there is absolutely nothing in the questions. Now come to the conclusions here. Conclusion 1, all cars are trains. All cars are trains. Where are cars? These are cars. Fine, these are trains. Is it possible? No. You can see clearly that there is no overlap. So this is cancelled, not possible. Look at the second one. Some trains are ships. Where are trains? These are trains, these are ships. Is it possible? Yes, some trains are ships is possible, because if you look at this part of trains, fine, this is all ships. So some trains are ships, definitely possible. It follows. Fine. Look at the third one. Some buses are bikes. If you look at this, some buses are bikes. Here it is, this is buses and this is bikes. There is absolutely no overlap here, and this gets cancelled here. And you look at the fourth one, some cars are buses. If you look at this is cars and this is buses. This is a definite overlap. It means that this follows. So 2 and 4 follow here. Fine, and the answer becomes option C, which all of you smart people have already given to me. Fine, so this is basics. This is basics. The only important thing when you look at a question like this is getting this diagram right. If you get this diagram right, this one, this is called minimum overlap Venn diagram. If you get this one right, you would not make any kind of mistake in Venn diagrams in all these questions ever. The important part is you need to understand when to make things overlap and when to make sure that they do not overlap. Let's move to the next question. I hope all of you got this one right. आदर्श, अगर ये मेथड ज़्यादा टाइम ले रहा है तो आप इसको मत यूज़ करिएगा. मैं आपको कई बार बोल चुका हूँ, इसको मत यूज़ करिए. अगर आपको यहाँ भी टाइम बर्बाद करना अच्छा नहीं लग रहा है तो आप जा सकते हैं. मुझे ये मेथड ज़्यादा टाइम नहीं लेता, 30 सेकंड में हो जाता है. आई डू इट क्विकली, आई एम एक्सप्लेनिंग इट टू यू, प्लीज़ अंडरस्टैंड. ऑल राइट, do this second part now. Do the second question. Do this question, give me the answer, then I'll explain this. I'll cover everything. I'll do possibility type, I'll do negative type, I'll do either or. Just give me some time and please do not keep asking for all these things. I'm saying I'll do everything. This agenda is divided into 2 days. Fine. Today I'll do everything that's required to get those 5 marks. Tomorrow would be reserved for all those myths, misconceptions, galat concepts, faltu concepts and all those things that I think should not be taught but still cause confusion to you nevertheless. So it's reserved for that and that new type syllogism. For that you need to get the basics first. So all of you are saying A, I'm sure all of you know how to do this. Let me move forward and explain to it very quickly. Statement 1, some cakes are roses. You draw cakes like this. Some cakes are roses, cakes and roses become something like this. All right, wonderful. Statement 2, all roses are trucks. Fine, roses and trucks. Fine, so all roses are trucks, roses are contained within trucks. Fine. Third one, no trucks are bricks. So these are bricks and these are trucks. In this, the only important point that you need to remember in this one is that you do this. You do this, now you know that trucks and bricks cannot overlap. Just do this. Fine, move forward. At least, okay, no trucks or bricks ho gaya. At least some bricks are hotels. You remove this part, at least here, some bricks are hotels, bricks and hotels mein overlap aa gaya. So this is your minimum overlap Venn diagram with which you can answer the questions directly. Look at conclusions now. Some trucks are cakes. If you look at trucks and cakes, is there an overlap? Yes, so it follows. Fine. Look at second one. Some bricks are roses. Some bricks are roses. If you look at this, bricks and roses. Fine. So this is bricks here and this is roses. Fine. Bricks and roses mein, is there an overlap? No. So this is cancelled here. Look at the third one now. All cakes are trucks. Fine, you can see this here. This is cakes and this is trucks. There is some overlap, but is it shown that all cakes are trucks? No. So this is again cancelled. And the fourth one, some hotels are cakes. So this is cakes here. Fine, and this is hotels. Some hotels are cake, you do not know if it's going to happen or not, so it's again not following. So the answer becomes just one follows, and which would be option A. So that's your answer for this question. Just one thing for all of you smart people who know the answer already, that's not for you probably. Just one thing here. Just remember this, that I am doing this directly from this diagram, this minimum overlap Venn diagram, for all those statements, all those conclusions that are positive in nature. I explained to you that theory. I explained that theory to you for a purpose. These are all positive statements. Some trucks are cakes, some bricks are roses, all cakes are trucks, some hotels are cakes. So you do it directly looking at what is shown to you in the Venn diagram if it's positive statements. Please remember this. Do not get this wrong. You do it directly from this Venn diagram if it's all positive statements. If it's a negative statement, if it's a possibility question, you have to tweak this Venn diagram, and that's why I explained that theory to you. I'm going to the next one. Again, a question with just positive statements, and I'll come to the negative ones. Right? Look at this one now. Give me the answer. Give me the answer quickly. I'll explain to you very quickly and then move on to the slightly tougher questions. Fine. My expectation from you here would be just to draw this minimum overlap Venn diagram that I just explained. I'm drawing it for you now. All tigers are dogs. Fine. So you draw tigers first. Fine. All tigers are dogs. Funny statement. This is dogs. So tigers are contained within dogs. Go to statement 2. Some tigers are cats. Fine. So this becomes tigers and cats. Do you draw it like this? Now look at this very carefully. Do you draw it like this? If you draw it like this, there is a problem here. When you draw dogs and tigers first and then cats, if you look at this region. This is extremely important. Don't get it wrong here. You get questions specifically based on this. If you look at this region here, when I draw something like this, I have just used these two statements here. All tigers are dogs and some tigers are cats. Fine. So though both of them look fine, but what I have done inadvertently here, जो मैंने यहाँ पर गलती से कर दिया वो ये कर दिया कि अगर मैं इस रीजन को देखता हूँ तो मैंने यहाँ पर एक डॉग्स और कैट्स के बीच का ओवरलैप बना दिया है जो कि नहीं होना चाहिए था. क्यों नहीं होना चाहिए था यहाँ पर? बिकॉज डॉग्स और कैट्स के बीच में जो भी ओवरलैप है वो टाइगर्स की वजह से. प्लीज अंडरस्टैंड दिस. आई हैव मेड दिस ओवरलैप हियर erroneously which should not have been there. Dogs and cats have got certain amount of overlapping, but that is happening only because of tigers. Look at this. All tigers are dogs, some tigers are cats. So dogs and this cats is connected only because of tigers. But this region here, this red region here does not have any tigers. It means this is erroneous. What I do here is that I draw it like this. Look at this. This is extremely important. If you do get it like this, if you do this, fine. So this overlap is still here. Fine, this overlap. But the thing is that this overlap between cats and dogs is happening only because of tigers. Fine. This dogs and cats are connected only because of tigers, and that's why it has to be drawn like this. You get this wrong so many times because you start with a statement like this. What generally happens is, I'm explaining to you in great detail because I know that these are problem areas. Fine. You draw tigers first. This is tigers. Then you draw dogs. Fine. Then you come to the second statement. Some tigers are cats. Fine. And you draw cats like this. And this is where the problem starts. If I give you a complicated question in this one, you'll get stuck. So draw it very neatly, very, very carefully. I'm moving forward to the next one now. All cats are lions. This is a simple one. Cats are contained within lions. Again, just remember one thing. If you look here, I have ensured that lions does not overlap and go into this region. Fine. So lions is just restricted to overlapping with dogs and tigers till the region that this till just that region that has been occupied with cats. Look at this. So I will not get into this region here. Fine. So just get this right. You draw it exactly like that. Let's move forward and draw the next one. All cows are lions. This is a simple one. Cows are drawn within lions. Again, what you need to be careful would be this region. So I have ensured that there is no intersection between cats and cows. No intersection between cats and cows. Cows are contained within lions but separated from cats. It does not mean that there can be no intersection. It just means, listen to me very carefully, it just means that this should not be a part of the minimum overlap Venn diagram. Fine. So when you are drawing minimum overlap, it means that you are just satisfying the minimum condition. Fine. That's the reason why if you are just talking about positive statements, they can be answered directly from this place. Fine. If you have to look for negative or possibilities, then you extend the diagram, and I'll have to look for possibilities in that case. This is okay for answering this question now. Look at this. Some dogs are lions. Yes, some dogs are lions. You can clearly see that some dogs are lions. This is correct. Some cows are dogs. You can see cows, dogs, not overlapping, not correct. Some lions are tigers. Yes, you can see that some lions are tigers. And the fourth one, all cats are dogs. This is again incorrect, not overlapping. So answer would be option D in this case. Only 1 and 3 follow. And this is it with the positive statements. You get this right and you answer all the questions in a jiffy. I mean, this is generally not the length of a syllogism question. You get 2-3 statements generally followed by 2-3 conclusions, but this is the lengthiest that you can get. 4 statements, 4 conclusions, still does not take more than 40-50 seconds if you get the Venn diagram right. But for this, the theory again becomes very important. Next question for you. Alright, so this is the next question now. I'm again, do not do it, I'm doing it myself because I want to explain something to you. If you look here, there are negative statements in this one. This is a negative statement, this is again a negative statement. Fine, so there are negative statements in this one, that's why I want to do it with you. Look at the first one. Some melons are kiwis. So I draw melons first and then I draw kiwis. 2. All grapes are plums. So grapes are drawn here, plums are drawn above grapes, right? This is fine. Third one, all kiwis are apples. Again, you know how to draw kiwis in apples, and no apples are grapes. So you do it again 15, 20, 30 seconds, you make the Venn diagram, minimum overlap Venn diagram. Now look at the options in this case and look at it very carefully. You come to the first conclusion, this one, this first conclusion here. It says some apples are melons. Now this is same as the last questions because this is a positive statement. If this is an affirmative statement, positive statement, तो मेरे को कुछ भी नहीं करना है. सीधा look at the Venn diagram and answer the question. Some apples are melons. Are they overlapping? Yes, apples and melons are overlapping. This is apples here, this is apples and this is melons. So this follows. Look at the next one. I'm just erasing this. Some grapes are kiwis. Grapes and kiwis overlapping? No. So this is ruled out. This does not follow. Now look at it very carefully. This third one. It says no apples are plums. Look at it very carefully. This is the important part here. When it says no apples are plums, this is a negative statement, and whenever you come across a negative statement, you cannot answer it directly using this Venn diagram. That's the only thing that you need to understand in this theory of syllogisms. There is absolutely nothing else. Whenever it's a negative statement, you cannot answer it directly. The reason is that the diagram that I have drawn here is just showing the minimum overlap. It's not discussing the possibilities. So when I am looking at a negative statement, I have to explore the possibilities as well. So if I look at the possibilities, no apples are plums. So this is apples here and this is plums. Fine. I know that apples and grapes here, this apples and grapes, this is grapes. They cannot overlap because it's shown by this thing. But is there a condition like this on apples and plums as well? No. Look at this. Can I do something like this? Now look at this modified Venn diagram. You do not draw it. I am just showing it to you to explain. Fine, you do not draw it, you do it mentally. If I just draw it like this, if you compare it to the previous one, have I violated any kind of condition here? No, I haven't violated any kind of condition here. Grapes are still part of plums. Apples and grapes are still disjoint sets, nothing changes. But what happens in the process is that I have proved here that there can be an overlap between apples and plums. Look at this overlap, this overlap. So there can be an overlap between apples and plums. So it means that my statement, no apples are plums, is not true. Apples can be plums. So apples can overlap with plums. Fine. So could you understand what I did? I extended this diagram to understand, to see that this is not necessarily true. This is a possibility. So what I do is that I conclude that this does not follow, and I come back to my Venn diagram again. This is the basic one. I come back to it after every statement. Fine, because this is the only one I draw. Look at the fourth one now. No melons are grapes. Fine, these are melons here and these are grapes. Fine. Do you think they can overlap in some condition? Just look at this one. If you look at this region here, this region, fine. This region, what does grapes have problem with? If you look at this, this is grapes. Grapes have a problem with apples. Fine. Apples do have some overlap with melons. It is this region. But this region here, this region of apples, this starred region, this is free to overlap with anybody. Fine. If you cannot do it directly, I'll show you the diagram as well. But this region here of melons is free to overlap with anybody. So it can be grapes as well. So if you look at it like this, if you think of it like this, again I do not violate any condition, but I can see an overlap between melons and grapes. What it means is that this statement again is not true. This does not follow. It means that the answer would be option A if only one follows. So this is what you do with negative statements. Just understand the theory. I am very happy with all these correct answers here. Just understand this theory. Whenever you see a negative statement, please ensure that you try extending the Venn diagram. The purpose of drawing a minimum overlap diagram is that you start with it and keep extending it to check for the possibilities. So check for the possibilities and check for the negative statements. I'm moving to the next one now and giving you a fresh question. Again, we'll do it very quickly. Again, this will not pose any problem to you. Just a minute. Okay, before I do this one, just a thing that I wanted to tell you, again an important part. Let's look at these two statements. For example, let's say there are two statements. One is all A are B and two is again something very basic, but people again make mistakes. Let's say these are the two statements. When you have to draw, there are a couple more. Fine, I'm just talking about these two for the moment. Assume kar lo aisa hi hai. When you start doing something like this, how do you proceed? All A are B means you will do this as A and then you will do this as B. Fine, this becomes all A are B. The moment you come to the second statement, how do you draw it? All A are C here. People make a mistake in these kind of statements. What they'll try doing is, या तो यहाँ पर C को बनाने की कोशिश करेंगे, they'll draw C like this or some place like that. It's not going to happen like this. So the moment you see a statement like this, you need to realize that I have to correct my Venn diagram. And how do you correct it? Just let me erase this part. What you do in a case like this is, if this is A, fine, B becomes something like this. This becomes B, fine. And if you look at this one, all A are C, this becomes your C. Look at it very carefully. This is extremely important. Fine. What you are doing here in this case is that you are ensuring that all the intersection between this B and this C is happening only because of A. What does my statement say? What do my statements say? All A are B and all A are C. So all A are B is satisfied here in this case and all A are C is also satisfied here. But what I am ensuring is that there is no excess intersection between B and C. People make mistakes here. That's why I am telling you this thing. Just remember this. Nothing special in it. But at times when you draw the first thing and you go to the second statement, you realize that I have to redraw it. So just redraw it, but do not get it wrong. Alright, move forward. So that's the question. Let's do it together. Look at the first one. At least some trams are autos. Some trams are autos would be drawn like this. This is autos. This is trams. Alright. Second one. All trams are cycles. All trams are cycles is fine. Third one. All cycles are trucks. This is again fine. No problems with anybody. And the fourth one. No trains are cycles. This is trains and this is cycles. If you look at trains and cycles, this line here and this cross would mean that there can be no overlap between trains and cycles. Answer the questions now. Look at the statements. Some trains, some trucks are autos. A positive statement, positive affirmative statement means I can answer it directly. What would it be? It follows, because you can see that there is an overlap between trucks and autos. Fine, trucks and autos के बीच में आप overlap यहाँ पर देख सकते हैं ना, this region. So this is an overlap. So it means that it follows. Go to the next one. No trams are trains. If you look at this one, this again follows. This is trains here. This one, this is trains, and this is trams. Fine. So there is no overlap between it. Positive statement I can answer directly. It follows. Go to the next one now. No trains or autos. If you look at this, no trains or autos, this is again very similar to the last one that we did. No trains or autos, this is trains here, this is trains, and this is autos here. Fine. You have to look for possibilities. Now, if you look at the starred region, this region here, this does not have a problem with trains. This trains has a problem with cycles. Cycles has an overlap with autos. But there is some part of autos that does not have have any kind of overlapping with cycles. It is this region. So this region can very well be trains. And if this can be trains, so it means that this statement is not true. You check the possibility and you negated it. And look at the last one. No, some trains are not trucks. Some trains are not trucks. If you look at this one, you have to again try to negate it. So it is here. If you put it inside this thing, this trucks. So here you can see that now all the trains are trucks. All the trains are trucks here because trains come inside trucks. So it means that this statement, this conclusion, some trains are not trucks, is again proven false. So it means that this would not follow. Again, what we did in this question was that when it comes to these two, I checked the possibilities by manipulating the Venn diagram. When it comes to the first two, these two, I read it straight away from the statements. This is it. You do not need to do anything else. What's your answer then? Answer becomes option B, which is only 1 and 2 follow. The next one. All right, so that's the next one for you. We'll again do it together because I know you are smart people, you will do it for me. Fine. Some pens are tables, these are pens, this becomes tables. All pens are desks, these are desks covering the pens. Third one, all tables are chairs, these are chairs. I do not think anybody would have a problem here. And fourth one is at least some papers are chairs. Fine. If you look at this, these are papers now. So this is your minimum overlap Venn diagram in this case. Fine, this is your minimum overlap Venn diagram. Now come to the conclusions. First one, some papers are desks. Some papers are desks can be seen directly here. Papers, desks, positive statement. Is there an overlap between paper and desks? No. So it's ruled out. It does not follow. Second one, no papers are tables. Again a negative one. If it's a negative one, so I have to look at the possibilities. Can I see an overlap between papers and tables happening? Can it happen? Yes. Look at this one. If I just put it like this, papers or chairs का जो connection है that would still retain ना. You remember that ना? Do not get confused here. If you look at this, the connection between papers and chairs is this one. At least some papers are chairs. So at least some papers are still chairs. There is an overlap, which is the only important thing. So if you look at it, it still remains. But what is happening in this process is that no papers are tables is negated. If you look at this one, no papers are tables is negated because I can see some overlap here. So this is again an extension of this diagram which proves to me that this statement, no papers are tables, is not necessarily true. It's a possibility, just a possibility. So what I do here is that I conclude that this does not follow. Look at the third one. Some desks are not chairs. Again, if you look at this, not chairs. Again a negative statement. What would you do? Try and negate it. How do you negate it? Some desks are not chairs. Look at this diagram. This is the original one, the minimum overlap diagram, and look at this one now. What I need to do is when I'm giving a statement like some desks are not chairs, what I need to do is that I have to check if all the desks can be accommodated inside chairs. Tabhi negate hoga na. It says some desks are not chairs. So I need to find a statement or I need to find a way which tells me that all the desks can be accommodated inside chairs. So if I extend the diagram like this, it does not violate any condition anywhere, fine, and it tells me that this is negated, fine. So you cross this again does not follow, fine. And look at this last one, some desks are not papers. Again, if you draw something like this, you can see that all the desks can be accommodated inside papers. So this diagram here, the one that I have drawn is an extended version, but it proves to me that statement, this conclusion 4 again does not follow because it can be negated. So what I did here was, if you look at this, what I did here was that for this statement, no papers or tables, I extended the diagram. For this one I extended, and for this one I extended and checked. For this first one, I did not do it because this is a positive statement. This is the crux of it. For possibility, for negative statements, do check by extending it without violating the condition. For positive statements, you can answer absolutely directly. There is absolutely no issue with that. All right, let's move forward. Okay. Now we come to possibility. That's the third type. Some people are asking some doubts. I'll address all the doubts once I'm done with the theory. This is not theory. Once I'm done with explaining this stuff to you, I'll take all your doubts, and then tomorrow is all doubts. Fine. This is the next one. Again, let's do it. We start with cats. All cats are rats. So this becomes all cats are rats. This is fine. This should be fine with everybody. Go to second one. Some jets are mats. So this is jets and these are mats. So there is a partial overlap between jets and mats because this is some jets are mats, right? Look at the third one now. No rats are jets. So what do? You make something like this. It shows you that rats and jets cannot overlap. Fine. Go to the next one now. All mats are fixed. So this becomes all mats are fixed. So this is a a fairly lengthy question in the sense that there are 4 statements, but you capture all these 4 statements with this one diagram here. This is just one diagram. Now come to the conclusion straight away. You come to the conclusions. Look at conclusion 1. No jets are cats. What is it? It's a negative statement. You need to try to negate it. Fine. Negative statement के आपको against जाने की कोशिश करनी होगी by extending the diagram. You look at jets and cats here. So these are jets and these are cats. Fine. So you can see that jets and rats are disjoint sets. They cannot overlap, and all the cats are contained within rats only. So it means that cats and jets cannot also overlap. So it means that this would follow. It means that jets and cats would also be disjoint sets. I hope you got it. Look at this. This is jets. This is rats. They are disjoint because there is a condition like that. Cats are contained completely within rats. So cats also cannot overlap with jets. It means that this statement follows. Alright, look at conclusion 2. No cats are mats. If you look at no cats are mats, this is important, I will explain it. No cats, where is cats here? Cats is this is cats. And where are mats? These are mats. Fine. So it says no cats are mats. It looks like that in the diagram, but you try extending the diagram now without violating the condition. What is the condition here? The conditions are given to you without violating the condition. Can you see of a way? You do not draw a modified diagram. Please understand this. You do not draw a modified diagram. You just try and understand it in your brain whether this is working or not. If you look at this one, just visualize this mentally. You can see here that I did not violate any condition here. I did not violate any condition here. Look at it again. It is the initial diagram. You can see all what is there in the second diagram as well, in this one now. But what I have ensured in the process is that when it comes to this statement which says that no cats are mats, I have shown here that this mats, this thing is overlapping with cats, this thing. Can you see this? This is the overlap here. Fine. So it means that this statement here, no cats are mats, is not true. Cats can be mats. Some cats can be mats, right? So we'll erase this, and it means that this does not follow. Next one, some cats being figs is a possibility. This can already be seen in this cats and figs. I mean the extension that I just draw for you, you can already see that this is figs and this is cats. So this is figs, so you can already see overlap between cats and figs. So some cats being figs is a possibility, is definitely true, it follows. And the next one, it is this thing, all rats being mats is a possibility. Look at this one, all rats being mats is a possibility. You can see that I can extend mats and figs to a large extent, to a very large extent, and now this rats here, fine, is contained completely within mats. I have not violated any condition. You do this in your brain, you do this mentally, you do not draw this extended diagram. You just draw that basic diagram and you need to visualize this part, and you can do it very easily if you just take care of these basic things. Fine, all these things like this crosses and all. What this cross does for you is that it kind of reminds you that this is the only constraint here, otherwise you can move anything everywhere. The conditions, the constraints in Venn diagrams come from all these things, all these crosses and all. Otherwise you can move anything anywhere. So I can draw something like this. You would not draw it when at the minimum level, but when you draw it later, you realize that this statement 4 also follows. So all rats being mats is a possibility. This again becomes a simple question. You draw this Venn diagram, right, the first one, and you do it very, very quickly. It can be done very quickly with 100% accuracy. इसमें कुछ गलत होने का है ही नहीं, हो ही नहीं सकता इसके अंदर कुछ गलत. नेक्स्ट चलते हैं. Okay. Alright, so this is an important one. Again, I'm coming to some parts which is important. This is again possibility. Again, let's draw it very quickly. How do you do it? I'm not giving you time to solve because so many of you have already seen my tutorial on this one and will give me answer before I do it, right? Look at this. All locks are doors. This is locks. This becomes doors here. Fine. Okay. All doors are bags would become something like this. All of you know how to draw it now. Look at 3. No tickets are doors. So you draw tickets and you draw something like this. This line means that doors and tickets cannot overlap. And the fourth one, all tickets are keys. Look at this one. You draw keys like this. So this becomes your minimum overlap Venn diagram. That's the figure that you need to draw, which you can draw in 20 seconds. Fine, if you are familiar with the basics. Now look at the conclusions here. Some locks are not tickets. Fine, it says this is locks here and this is tickets here. Fine, if you look at this, you can see that there is a problem between doors and tickets. This is doors and this is tickets. So there is a problem, and locks are contained completely within doors only. Fine, so what it tells me is that this is true. Some locks are not tickets is definitely true. All the locks that are within this thing cannot be a part of tickets. Move forward, look at the second one. All locks, okay, I'll show it later. Look at the second one now. All locks being keys is a possibility. This is the minimum overlap diagram. I'll just erase this. Look at the second one. All locks being keys is a possibility. Fine, this is locks here and this is keys. So that's locks and this is keys. It says that all locks being keys is a possibility. Fine. So can this locks thing go inside keys? Yes, it can. It cannot go inside keys, but keys can become bigger. What is the problem with keys? Can you see a condition or constraint on keys? Absolutely not. So if I extend keys like this, look at this. It can be drawn like this. So this becomes my new keys. If I draw something like this, you can see that all the locks here, all the locks, this is locks, are contained within keys now. So this is again a possibility. So it means that it follows in this case. So you saw it, you do it with extending the diagram. All right, the next one, this is the next one. All bags being keys is a possibility. Again, you can look at it very clearly. If you extend it, all the bags can be accommodated inside keys. So this is keys, this one, and this is bags, this one. So you can see I have not violated any condition, but bags come inside keys in this thing. So all bags being keys is possible, it again follows. Fine, and if I erase this one, look at the fourth one now. All keys being bags is a possibility. So what I am doing now is that I have to check if all keys can be bags. Fine, if you look at this, bags can be extended now. It is the original diagram, Venn diagram, original minimum overlap diagram. I have to compare keys and bags now. So this is bags and this is keys. If you look at these, you have to try to negate this. Fine, in fact not negate, you have to look at this possibility. So you can see that in this diagram, bags and keys are shown to be disjoint. But can you extend bags to take keys inside? Yes, all keys being bags is a possibility. How would it become like this? When you extend bags, how do you extend bags? Like this. So if you extend bags like this, now you can see here that all the keys, this thing is contained within bags. So this is bags and this is keys. I have not violated any condition in this diagram, and you can still see that all the keys are inside bags. So this is again true. So it follows. So the answer would become option D, all of them follow. So all the conditions follow and that becomes your answer. Now I will give you a question that was not a part of that tutorial that all of you have seen and giving me my answers. Fine, so that's the question. Just do it now and give me the correct answer for this one. I will take a minute's break now. I am hoping that you will not answer in 10 seconds now. Okay, some people are saying problem with the first one. I'm just going back. All of you do this. I'll just explain the first one if people have problem. I'll just going back here. Just a minute. Okay, so what is the problem here? Let me just explain it again. You're saying some locks are not tickets. Let me just try and explain this for you. That's the, you're talking about first conclusion. Let me just come back to it. Give me a moment. Just a moment. So that's your minimum overlap Venn diagram. You are talking about this one. Some locks are not tickets. Fine, look at locks and tickets. This is locks here and this is tickets. Fine, you can see here that there is a problem between tickets, this tickets and doors. What is the problem? They cannot overlap. Why? Because they are disjoint sets. Now you can see here that doors and tickets are disjoint sets. They cannot overlap. What it means is that since locks is contained completely within doors, देख रहे हो ना आप यहाँ पर ऐसा ही है ना, locks are contained completely within doors, so there can be no overlap between locks and tickets as well. Since there is no overlap between doors and tickets, this is doors, this thing, and this is tickets, fine, there is no overlap, fine, because they are disjoint sets. Now since locks are contained completely within doors, there can be no overlap between locks and tickets as well. So you already know that locks and tickets cannot overlap, and that's why it's true, some locks are not tickets. You know that this is one of the ways of representing some locks are not tickets, some A are not B. जो मैं आपको diagrams दिखा रहा था वो इसी के लिए दिखा रहा था. So this is another way of representing some locks are not tickets, that locks and tickets are also disjoint. That was a case there. Go back to the theory if you find a problem here. Moving forward now. Okay, give me the answer to this one now, the question that I gave you. Who got it? Okay, this is the question now. This is very similar to the last one. I just made a small change here. Let me see how many you can give you the correct answer. Shiv, please watch it again. I have explained everything thoroughly. You will get it. There are 6 tutorials of mine on our channel as well. Fine. I have again explained the same thing in detail. Please watch them as well. Please watch this. You will get it. So there is nothing extra that I am going to tell you if I repeat it. Fine. So let me just continue like this. Please watch it again, the part that you do not understand. So all of you are saying E. Yes, E is the correct answer. Fine. I took this question for a reason here. When I took this question, this is not a part of my initial thing here. I took it for a reason. The reason is that there is a special statement here. Some tickets are not doors. Fine. So many of you are saying that you get this some not kind of statements. This is a some not kind of statement here in your statements as well. Conclusions में तो आता ही है. At times you say that this appears in your statements as well. So that's why I wanted to show to you how do you draw it. Fine. Just look at it now. I proceed in a similar manner. Statement 1. All locks are doors. How you draw it? This is locks, this is doors. So it remains exactly the same. Second one, all doors are bags. You again draw it like this. This is bags now. Then you come to the third one. Some tickets are not doors. Now there can be multiple ways of drawing it. I draw it like this. Fine. Again, because I'm showing minimum overlap here. I draw it like this. You may choose to draw it in a different manner. I'll tell you why I draw it like this. I draw it like this, and then what I know from this is, since you understand that some tickets are not doors, there are 2-3 possibilities. They can be disjoint sets, fine. They can be a partial overlap and stuff like that. I do this because I'm drawing a minimum overlap diagram. Minimum overlap diagram means that I have to make sure that tickets and doors overlap to the minimum possible extent. So when you look at this one, some tickets are not doors. When would the minimum overlap happen? The minimum overlap would happen when they are disjoint. Very simple, fine. But what I would not do here is draw something like this, fine. What I do with this is, when they are disjoint sets, I do something like this. It tells me that tickets and doors cannot be manipulated in a way in which they can overlap. Please listen to it very carefully. This is extremely important even for the smart people out there who know everything. This is extremely important. When you draw some tickets are not doors, please remember that you do not do this. You do not do this. This is done when you have to, kind of remind yourself at a later stage that tickets and doors cannot overlap. So you know that they cannot be manipulated to overlap. That's why I do this. So what I'll do here is, in place of this, I just need to remind myself at a later stage. Look at the statement, some tickets are not doors. I just need to remind myself here that there has to be some part of tickets that is outside doors. Listen to it very carefully. This statement here just tells me that there has to be some part of tickets that is outside doors. So what I do for myself to remind myself this of this condition later here is that I draw something like this. I draw this and I call it T, and then I draw this and I call it D. So T stands for obviously tickets and D stands for doors. So when I draw this, it shows T inside D. Fine. I put a cross here. I do it for my reference, just for my reference. I do it for my reference because it reminds me without going back to this set of 4 statements here, because what I am doing here by drawing this diagram is that I eliminate this need to go back to the statements. That's why I do the Venn diagrams. No, otherwise that's not required at all. You can go back to the statements and solve the question. Now I'm drawing this. It reminds me when I do something like this. T ko overlap karte hue there is a D, and then I put a cross here. This reminds me that I have to make sure that I do not put T inside D. Why? Because if I do this, then this condition is violated. Some tickets are not doors. It means that there have to be some tickets that are outside doors. It means that if I do this, I'll remember that tickets cannot go inside doors, or tickets cannot be equal to doors. Fine, tickets either has to be larger than doors, or there is no overlap, or there has to be a partial overlap. I hope you understand this point. And you just keep it like this, and then you remember this. और उसमें कुछ भी नहीं करना है. Let's go to the 4th one now. All tickets are keys. How do you draw it? All tickets are keys, again in a similar manner. Fine. So that's your minimum overlap diagram in this case, and now you again solve it in a similar manner. But now the things have changed slightly here. Look at first question. This is important even for those people who have watched my tutorials before. This is important. Look at the first one now. Some locks are not tickets. Fine. What are you comparing to? What are the two that you are comparing here? You are comparing tickets with locks here. Fine. It says some locks are not tickets. If you look here, you can see here that locks and tickets are disjoint, shown to be disjoint, but they are not disjoint. They are free to move around. What is my condition? My condition here is that tickets should not be completely engulfed within doors. That is my only condition here. Fine. So if I ensure that I do not violate this condition, I can manipulate locks and tickets still. Now look at this. It says some locks are not tickets. So can I ensure that this statement is negated? Can I ensure in a way that this is negative? How do you do this? Some locks are not tickets. Fine. Some locks are not tickets का क्या मतलब होगा? Some locks are not tickets का मतलब ये होगा कि कुछ ऐसे लॉक्स हैं जो कि टिकट्स नहीं है. अगर मेरे को इसको निगेट करना है तो मेरे को ये इंश्योर करना है कि सारे के सारे लॉक्स टिकट्स के अंदर चले जाएं. If I have to negate statement 1, I have to ensure that all the locks are within tickets. Then this would be negated. How do I do it? Now I'll not draw it for you. Just visualize this. I put this whole piece. I pick this whole piece up. This whole piece. Listen to it very carefully. Fine. And I put it inside tickets. यहाँ पर डाल दूंगा मैं इस सारे piece को. So I do it like this. This is locks. This is doors. And this is bags. Can I do it? Yes, I can do it. What is the problem? Do I violate any condition? No. There is no violation. Absolutely. The only condition that has to ensure is followed is that tickets are not engulfed within doors. But when I draw these three inside tickets here, fine, these are these three only. I am ensuring that tickets are there is some part of tickets that's outside doors. Fine, you can see it here. So if I do this, now I can negate this one. Some locks are not tickets. No, locks can be tickets. Some locks are not tickets. In fact, I can show that all the locks can be tickets. This statement would be negated when I prove that all the locks can be tickets, and this proves here that all the locks can be tickets. I just show it slightly more neatly to you. So it happens like this. This becomes locks, this becomes doors, and this becomes bags. So it does not violate any condition, and you can see that statement is negated. So this thing is negated here. I hope you understand this. This is extremely critical if you are bothered with this some not statements. This is the only thing that you do it in this case. Fine. Just let's move forward now. I'll erase this part. Fine. And this is eliminated. Look at the second one now. Okay, I eliminated this as well. Okay, you remember the statement, so it's not really required. Just let me draw it quickly for you. It was drawn like this. It shows that tickets cannot go completely within doors. Fine, that's the only thing. Look at the second one now. Some tickets are not bags. What are you comparing now? These are tickets and these are bags. So it says that there are some tickets that cannot be bags. Is it true? Is it true? हो सकता है कि ऐसा some tickets are not bags. अगर मेरे को इसको negate करना है, if I have to negate this statement, what do I prove? Some tickets are not bags को negate करने के लिए what do I prove? I prove that all the tickets can go inside bags. Can I do it? Yes, very easily. Some tickets are not bags को negate करने के लिए मैं क्या करूंगा? Just think like that. I have to try to negate this statement. What does the statement say? Some tickets are not bags. Fine. So it means I just need to prove that all the tickets can go within bags. Is it possible? Yes. अब इसको सिर्फ विजुअलाइज करना है, ड्रॉ नहीं करना. अगर मैं इस बैग्स को एक्सटेंड कर दूं, लेट्स से आई एम जस्ट शोइंग इट टू यू लाइक दिस. अगर मैं इस बैग्स को एक्सटेंड करके ऐसा कुछ बना दूं, समथिंग लाइक दिस. इफ आई एक्सटेंड इट हियर, फाइन, तो ये उसकी बाउंड्री नहीं रह जाएगी. एम आई वायलेटिंग एनी कंडीशन हियर? एब्सोल्युटली नॉट. इज दिस कंडीशन बीइंग वायलेटेड? टी वाली कंडीशन? नो, इट्स नॉट बीइंग वायलेटेड बिकॉज ये कंडीशन तो डोर्स के साथ में था, बैग्स के साथ में नहीं था. बट व्हाट हैज हैपेंड इन द प्रोसेस इज that now I can see that all the tickets are contained within bags. Now you can see here, this is the bags boundary, this new boundary here, fine, this is the bags boundary, and you can see that all the tickets, this one is contained completely within bags. Fine, so this happens, this is possible, so it means again that this does not follow. I'll clean the screen for you and move forward. This is a sum not example that you keep worrying about. So this is not happening, this is not happening. Look at the third one now. All tickets being locks is a possibility. Fine. So I am now saying that all tickets being locks. So this is tickets, fine, and this is locks. So it says that all tickets being locks is a possibility. Can I put tickets somehow inside this region? This is not possible. The reason is simple, that if I put this tickets inside locks, locks is already contained inside doors. And if I remember it right, I do not need to draw it again and again. Now you remember it. Tickets cannot go inside doors completely. So if I put tickets inside locks in this region, locks is contained within doors. So it would come within doors as well. So if I put tickets inside locks, tickets go inside doors as well, which is not possible because of this condition. So it is also ruled out here. And look at the fourth one. I'll again clean it for you. Look at the fourth one here. This is cancelled, this is cancelled, this is cancelled. All keys being doors is a possibility. Again, all keys being doors. Now, if you have to put keys within doors, what do? You have to extend doors. If you extend doors here, fine, to include keys, fine, all the tickets are contained completely within keys. All these tickets are contained within keys. So if I extend this doors to contain keys, all the tickets would also come inside doors. Isn't it obvious? I somehow extend doors to include keys. If doors extend keys, I'm not drawing it for you because you have to think about it mentally. I drew all this for you just to explain. If I extend doors somehow to include keys, fine, tickets is a part of keys, so it means tickets would also completely come within doors. If tickets come within doors here, this thing, just if tickets come within this region, that's a violation of the condition. So it means all keys being doors is not possible. If I do all, if I put all the keys inside doors, all the tickets also go inside doors, which would be a violation of condition given in statement 3. So it means that this is also not possible, and the answer to this would be statement E. Fine. Now a word of caution here. I have not seen many questions in which you get this sum not. So I framed this for you, and I framed all the 4 conclusions. So generally if it's there, you would not get all the conclusions in which this condition is used. But still, for I mean, you do not know what can come in the exam, just use this method. Draw this quickly and do this. It'll remind you, it'll keep reminding you that I cannot put T inside D completely, and that's the job done for you. Otherwise you can draw it as completely disjoint sets without any problem. There is absolutely no issue with it. If somebody has a problem with this, please tell me now. I'm willing to go the extra mile in this, and then we'll move forward. This is, अरे यार इसको छोड़ दो ना, this is a typo यार, just ignore this, this is not important, cancel this whole thing, this is the important part, this is not an actual exam, I made it for you, so it's a typo, just ignore this, none of these becomes your option because all 4 are not following. This is important for you to understand the methodology, don't go to these typos here, this is not an actual exam question. That's the only way you do questions like this. Whenever there is a sum not, please follow this. Some people are again saying they have a problem with the first one. I am just explaining this conclusion once more, just once more very quickly. Otherwise go back to the video and watch it again. Just bear with me for all of you who understood this. This is the diagram in front of you. Fine, that's your conclusion. Some lots are not tickets. Fine, what I know is that some tickets are not doors. Some tickets are not doors means that there has to be, listen to me very carefully, that there has to be some part of tickets that is outside doors. That is the only meaning of some tickets are not doors. So what I do is that I make something like this. This is T and this is D. It shows doors. I'll just put a cross here. It reminds me that I cannot put tickets inside doors. Now look at conclusion 1. Some locks are not tickets. These are locks and these are tickets. Fine. You have to, try to manipulate it in a way that, you get to know whether this is possible or not. If you look at this, some locks are not tickets. You know that tickets cannot go inside doors. So it means that there have to be, this tickets here cannot be put completely, just a minute. This tickets here cannot be put inside this thing here. Fine. But you know that locks is contained completely within doors. Fine. If locks is contained completely within doors, fine, and tickets cannot go inside this thing, doors. Fine. So how is this possible? This is not possible. Some locks are not tickets. Obviously this would happen. When can, think like this, when can all the locks be tickets? All the locks can be tickets only under one condition. Fine. All the locks can be tickets. Fine, when I put tickets inside this region, this whole region, because locks are completely within doors. Fine, so unless I put tickets completely within doors, this is not possible. And if I put tickets completely within doors, then this condition is violated. That's why it's not possible, and this conclusion does not follow. Please get it. Watch it again. Plus, please do it. This is important. Moving forward now. Guys, you guys are extremely impatient. If that is your doubt or your problem, you do not have a problem. If somebody else's problem, then you keep saying, keep poking me, move forward. If I keep moving forward, I know everything. I have to explain it to you here. Just to be a little patient. Please bear with me. I'm not doing this for myself. Alright, this is your next question. This is again very important for all of you who know this. Still, I would request, please concentrate. This is a slight aberration in the ways statements are given. That's why I'm focusing on this question. Please read it. I'll draw it for you then. Please read it, give it half a minute for people who have not seen those tutorials, and I'll draw it for you. Please read it first. I'm not interested in the answer. I know a lot of you already know the answer. I'm just interested in explaining something to you here. All right, let's proceed. Let's draw it like the way we do it in rest of the questions. Some jugs are mugs. This is jugs, this is mugs, nobody would have a problem. Second, at least some mugs are plates. Fine, at least means nothing here. Fine, so this is nothing. Some mugs are plates is drawn like this. Plates and jugs are separated because we do not need to do it in a minimum overlap Venn diagram. Third one, all plates are forks. You draw forks like this, right? And the fourth one, all forks are spoons. Fine, so you draw something like this. So that's your minimum overlap Venn diagram in this question. That's the final one. Now come to the conclusions. Some plates not being spoons is a possibility. Now this is again a slightly complicated statement. Some plates not being spoons. Where are plates? Where are spoons? Look at this. This is plates here, and this is spoons. Fine. It says some plates not being spoons is a possibility. You already know that plates here are contained within forks completely, and forks are contained within spoons. So it means that it's not possible. Plates have to be contained within spoons. Plates has to be contained within spoons. Is it possible? No. So it means that this possibility is not okay with us. It does not follow. It's violating the condition. Move forward. Look at the next one. Some forks which are not plates are mugs. Now this is the one that I am actually interested in. Listen to it carefully again. Whenever I see this not, there is a tendency among some people, they'll think that this is a negative statement. I'm explaining it to you just once. Please listen to it carefully. This is an ancillary statement here, which are not plates. Fine. This is not a main statement. Just look at it like this. This statement 2 is nothing but this thing. Some forks are mugs. What is some forks are mugs? Some forks are mugs are basically a positive statement. So this statement 2 here is a positive statement. It's an affirmative statement. This is not a negative statement. Whenever it's something which is affirmative, you look at possibilities. You look at extending the diagram. This is extremely important. People got very confused when I did it first time in that other tutorial. Please remember, which are not plated is an additional part. Fine. It's the kind of stuff that you do with which and that. The statement is of the form some folks are mugs. So please realize that it's a positive statement, right? If you realize this, then you have to look at you have to ensure that you look at the diagram in its current form and not extend. Had this been a negative statement, you would have extended the diagram. But this is an ancillary part and you do not extend. Now look at plates, forks and mugs. These are forks and these are mugs. So this is forks and this is mugs. So it says some forks are mugs. अगर सिर्फ इतना होता, had this just mean some forks are mugs, तो हम देख ही सकते हैं, this is the intersection over here, some forks are mugs. But it says some forks which are not plates are mugs. Now this is plates here, and you already know that same thing that I've been repeating again and again and again. This intersection between mugs and forks, listen to it carefully, the intersection between mugs and forks is happening only because of plates. Why? Because initially there was an intersection between mugs and plates. Fine. Then you came to know that plates is contained within forks, so you draw forks. When you drew forks, then there was an intersection between mugs and forks, but which is happening because of plates only. That's why when you are given a statement like some forks which are not plates are mugs, it does not follow. It's not a necessary thing. It's just a possibility. Fine. Why? Because this intersection, I'll clean it again and show it to you. This intersection is happening only because of plates. So this plates go from the picture. So the part of forks that is left with me is this part. Fine. Now this part may intersect with mugs, may not intersect with mugs. but it's not definitely true. Fine, you say that a statement follows when it's definitely true, right? So it means if you just look at this thing, I've just drawn it to make you understand. If you look at this region here, this region can be a region which makes this statement true. What is this region is? What is this region? If you look at this region here, this is the region of forks which is not plates. Fine, plates की boundary तो यहाँ खत्म हो जाती है ना, plates is ended here. So this region is forks which is not plates but which are mugs. But this is only a possibility. Fine, the original diagram that I drew, the minimum overlap diagram, did not talk about possibility. Fine, so this is not possibility, this is a possibility, this is not a concrete condition. So had the statement been some folks which are not plates are mugs is a possibility, then I would have said yes. Fine, but in my minimum overlap diagram this was not there, so it means that this would not follow. Please understand this part, this is extremely important for all of you who know it. Very good, wonderful. Who do not understand, please watch it again, make sure that you understand this. Alright, so this is the initial diagram that I have come back to. Look at the next one. All jugs being spoons is a possibility. Where are jugs? This is jugs and this is spoons. All jugs being spoons is a possibility. It looks simple to me. Fine, you just extend spoons like this. This is spoons, there is no condition, there is no disjoint sets condition, nothing like that. You just extend spoons, that becomes possible, and this is okay. So this statement follows. Third conclusion follows. And let's move forward to the next one now. This is the original condition of the minimum overlap diagram. Look at the fourth one. This again is very much like the second conclusion. Look at it properly, carefully. Some spoons which are not forks being mugs is a possibility. Now in this case I'll look at a possibility. Why? I'll just exclude this part first. इसको मैं छोड़ देता हूँ एक बार के लिए. What does the statement read? Some spoons being mugs is a possibility. So this is a possibility kind of statement. When it's a possibility kind of statement, I'll extend the diagram. I am free to extend the diagram. If I extend the diagram, then I have to check if this is possible or not. Now look at it again. I am free to extend this. Some spoons which are not forks being mugs is a possibility. Fine, this is that same thing that I did in statement 2 here. Let me just do this. Look at this one. If I just draw this, am I violating any condition? Look at this second diagram. What have I done? What I have done is, now there is this part of spoons. This is spoons here. This is spoons. There is this part of spoons, this part here, this part. I'll just show it like this. This starred part here. If you look at this, now this part of spoons, this is not forks. Forks is just restricted to this part, this brown boundary. Now this part here, this part, all this part is mugs, fine, but not forks. This is not forks, but this is mugs. So this is possible. So this was not there in the initial Venn diagram because that was a minimum overlap Venn diagram. So had this question been some spoons which are not forks is mugs, or some spoons which are not forks are mugs, so it would be false in that case. It does not follow. But it's asking me about possibility. Possibility के केस में I am free to extend the diagram. Possibility के केस में मैं diagram को extend करके check कर सकता हूँ. जब मैंने extend करके check करा, I get this diagram and this proves to me that there indeed can be some spoons जो कि forks नहीं हैं, which are not forks but they are still mugs. तो जब मैं इसको extend करता हूँ तो मुझे पता चलता है कि कुछ ऐसे spoons हो सकते हैं जो कि forks नहीं हैं but वो mugs हो सकते हैं. I'll just clean this. Look at this once more. This is the region. Fine. So these are spoons which are not forks. These are spoons which are not forks but which are mugs. Look at this carefully. It's not violating any condition and this is a possibility. So it means that this thing follows. So my answer would be whatever it is, none of these 3 and 4, which is none of the options here. Fine. So that's the important part here. Just be very, very careful with this which are not plates type of conditions. This is basically this is nothing new. This is just a convoluted condition. What is convoluted? Chalo, I'll give you a new word today. If you do not know it, look for this word. This is just a convoluted condition, slightly twisted condition that is given to you. Just be careful. The way would be remove this part, look at whether this is a possibility, negative or a positive statement. When you look at it, then you kind of figure out in your mind whether this is going to work or not, and that's how you do it. Fine, this is it with this kind of statement. I'll move forward and just a moment. Okay. All right. So I am now coming to either or. The questions of the form either or. Just answer this very quickly. All of you now know this. We'll finish this up very fast now. Just do this. I'm again requesting all of you who still do not get this, please give it some time. It'll be worth the time, it'll be worth the effort. This is 5 solid marks. You cannot lose anything here. This is 5 out of 5 if you get the concept. Bimal, I explained it in detail. Please watch the video again. I will not tell you anything new. It's not that, you know, I do not want to work hard. It's just that I would not tell you anything new if I repeat it again. Please watch it again. Watch it 2 times, 3 times. You will get the concept. Alright, let me just solve this now. It's a simple one. Again, just 2 conclusions, so you can check it very, very quickly. Let me just draw the diagram. This is canines, this is cats, fine. This is felines. Now all of you know how to do it. This is apes. No apes are canines, you draw something like this, and some dogs are apes, you draw something like this. This is your Venn diagram. If you get this right, you get everything right. Look at the statement now. Some dogs are not cats. If it's some dogs are not cats, what do? It's a negative statement. You try negating this negative statement. You look for an exception to this negative statement. आप कोशिश करते हो जैसे ही आपको एक नेगेटिव स्टेटमेंट मिलता है कि उसको मैं गलत प्रूव करूं. सो सम डॉग्स आर नॉट कैट्स को गलत प्रूव करने के लिए आप क्या करेंगे? आप सारे के सारे डॉग्स को कैट्स के अंदर शामिल करना चाहेंगे. यू वुड वांट टू इंक्लूड ऑल द डॉग्स इनसाइड कैट्स. इज इट पॉसिबल? Yes, it's possible. Am I violating the condition? Am I violating any condition in this one? No. मैं इस वाले एक्सटेंशन से इस डायग्राम के कोई भी कंडीशन वायलेट कर रहा हूं? नहीं कर रहा. सो आई कैन सी that all the dogs are contained within cats, so it means that this is false. I'll just put a cross over it. Fine, I'll come back to my original diagram. Now look at the second one. No canines are felines. Again a negative statement. No canines are felines. Again, can I, can I draw something like this? Absolutely not. The reason is, if you look at this, this is felines here. Fine, and that's canines. Canines and apes have a condition of mutual exclusivity. So canines and apes are disjoint sets. But you can see here that all the felines are contained completely within apes. So when canines and apes cannot overlap, even canines and felines would not overlap. Canines and felines would not overlap because felines are contained completely within apes. So it means that this condition is true. No canines or felines is fine. So the answer here would be, in this case, option B. If only 2 follows. I am moving forward to the next one. Yes, only 2. Wonderful. The next one. Just keep a be on the lookout for a googly here. I'll give you a slightly different one in the coming ones. For all of you who have already seen this, do not bother. All right. So this is the. Just a moment. All right. So what I have done is that I have retained that same minimum overlap diagram so that you do not need to make it again. I know that all of you understood how to make that minimum overlap diagram. I have just changed the possibility, just changed the conclusions to do it for you. Now look at this conclusion. All felines being dogs is a possibility. It's a possibility. What do? You do it like this. This is felines. I'll just explain slightly. This is felines and these are dogs. It says all felines being dogs is a possibility. इसका मतलब हुआ कि ये बोल रहा है कि सारे के सारे felines dogs के अंदर आ सकते हैं. आ सकते हैं क्या? Easily आ सकते हैं. इसमें कंडीशन में दिक्कत ही कहाँ है? दिक्कत जो है इसमें कंडीशन में सिर्फ canines और felines के बीच में, यहाँ कंडीशन में दिक्कत है. बट ये तो कहीं भी जा सकता है ना. It can do anything. So just look at this. Look at it like this. Am I violating any condition here? Absolutely not. No condition violated. And now all felines being dogs is a possibility? Yes, it's a possibility. So it means that it follows. Fine. So this follows. Look at the next one now. I come back to my original diagram now. No dogs are canines. Where are dogs and canines here? This is dogs and these are canines. It says that dogs and canines are mutually exclusive set. Is it okay? Are they mutually exclusive? Again, look at the problem. Where is the problem? Canines and felines have a problem. They cannot intersect. They cannot overlap. And there is some portion here of dogs that is within apes, but felines से तो कोई problem ही नहीं है. So if you look at dogs and canines, this dogs and this canines, this is dogs and this is canines. Do they have a problem with each other? Absolutely not. So if I draw something like this, I would not draw it. I would just kind of do it in my mind. If I draw something like this here, fine, I can see here that this is not true. Some dogs can be canines, so this can overlap. So the answer becomes option A. Yes, all of you are right here. Somebody is saying E, no, both would not follow. It would be like this. This is possible. Whenever you have a doubt in this, just think like this. If you look at all the conditions, if you look at all what is given here, am I violating anything here? With this diagram, I am not violating anything, and I am proving that no dogs are canines is false. Dogs can be canines. If you have to negate this no dogs are canines, what do? You try and make an overlap between canines and dogs, which is what I have done here precisely. This is okay. So let's go to the next one now. This is A. That is your next set of conditions, this one now. All cats being dogs is a possibility. All cats being dogs is a possibility is very simple. You can see here, this is dogs. So you can obviously extend this set. How do we do it? I extend it like this. So all cats become dogs. So this follows. This is a simple one. Look at the second one now. I'll just bring the diagram back to its original position. Some cats are not apes. Some cats are not apes. Fine. If you look at this, this is true. The reason is, again, a simple one. If you look at this, there is an intersection. There is this condition between canines and apes. If you look at this condition, some part of cats would be canines as well. यहाँ भी तो cats होंगे ना. You look at region, there will be cats as well because all the canines are cats. So these cats inside this box, the small one, this part, which are canines, can never be apes. So इसका मतलब क्या हुआ कि there are always some cats that are not apes. Which are those cats which are not apes? Just to take this logic a bit forward, it is those cats that are canines that can never be apes. So it means that this statement is true. And what becomes your answer in this case? It would be option E, if both 1 and 2 follow. It would be option E, both 1 and 2 follow. The next one, this is the next set of conditions here. Okay, all dogs being canines is a possibility. I am just showing you all the tweaking that is possible in a diagram. The only thing that you need to do properly to get questions like this right is to just draw this one diagram, and then it's job done for you. All dogs being canines is a possibility. This is dogs, this is canines. Is this possible? Can you extend the set of canines to include all the dogs inside? Is it possible? It will not be possible. The reason is, it's not possible. The reason is this region. Just a minute. This region. If you look at this region here, this region, this is the region of dogs that's intersecting with apes. Fine. And you can see that canines and apes, they are disjoint sets. Fine. So all the dogs, listen to me very carefully, all the dogs that are apes can never be canines. So all dogs being canines is not possible. So this does not follow. Look at the second one now. All cats being felines is a possibility. Fine. Is it possible? Again, not possible. All cats being felines, these are cats here and these are felines. Fine. All cats, can I put cats inside felines? No. Why I cannot put it? Because felines are contained completely within apes. So when felines are contained completely within apes, if I try putting cats inside it, canines would also come inside it, which would violate the condition. So this again does not follow, and if it does not follow, the answer has to be option D, if neither 1 nor 2 follows. Fine, just be very careful. I am coming to that tricky part now. Okay, this is your next set of conditions. This is slightly different. This is slightly different. Look at it now. Some cats are apes. Fine, if you look at this, some cats are apes. This is a positive statement. If you look at this thing, this is cats and these are apes. If I am saying some cats are apes here, fine, you have to see it directly from this minimum overlap Venn diagram. What is shown here? That it's not followed. It means that this does not follow. Cats, apes shown as disjoint here, or shown as non-overlapping. I should not say disjoint, shown as non-overlapping here. So it means that it does not follow. Fine, let's clean it, move forward. No cats are apes. If you look at this, no cats are apes. Is it true? Can cats and apes overlap? Yes, they can overlap. Look at this one. Again, I have shown a lot of questions like this to you earlier as well. If you look at this, does it violate any condition? No. Is the condition between canines and apes intact? This canines and apes intact? Yes, canines and apes condition is still intact. They are still disjoint. But now if you look at this, no cats are apes, you can see that this cats here intersects with apes. So that's possible. So that's possible without violating any condition. It means that it does not follow. Fine. So it becomes something like this. Now comes the important part here. Fine. If you look at this, there are two options that can be possible answers here. It can be either this thing, either this one or this one. Otherwise, if you look at the last question, I marked the answer as neither 1 nor 2 follows. But this would be different. Now just remember this. Now just remember this part. If you get a condition like this in which both are not following, and the statements are like this. What are these statements like? These are statements sum A or B. This is statement 1 and no A or B. If you get statements like this, these two statements and both are false individually. If you get statements like this and both are false individually, it is the same type. So this is false and this is false individually. But there is a statement which says if either one or two follows, then the answer has to be that option. Just remember this. So had this option C not been there, I would have marked D, but it's generally there in all these type of questions. Just remember this. This is case 1. There are just two cases in which either or works. This is first case. Sum A or B, no A or B. Find sum A or B, no A or B. If they are false simultaneously, then you mark the answer as either of the two, which in this case is option C. Please remember this. This is extremely important. You make the mistake of marking the answer as option D when you are in a hurry in questions like this. Let's move forward. Okay, this is the next one. Look at this now. Okay, it says the conditions remain the same, so there is nothing to do here. All dogs are apes. If you look at this, all dogs are apes. This is a positive statement. These are apes. These are dogs. Are all dogs apes here? No, this is not. All dogs are not shown to be apes. It means that this statement does not follow. You can understand it very simply just by looking at the minimum overlap diagram. Now look at the second one. What does it say? Some dogs are not apes. It says some dogs are not apes. It means that if I have to negate this, I have to try to negate this because there is this not here. When there is this not, I try and extend the diagram. So it says some dogs are not apes. So if I do something like this, just look at this thing. If I put dogs completely inside felines, so all the dogs go inside apes as well. Now this condition is negated without violating any condition. ये condition इसमें पूरी तरीके से negate हो गया, कोई भी condition violate करे बिना. अगर आप यहाँ देखोगे, ये क्या बोलता था? Some dogs are not apes. But अब यहाँ पर क्या हो रहा है? What is happening here? All the dogs are apes because all the dogs are contained within apes. So it means that this again is not true. So it again does not follow. Now again comes the important part. This is, just a moment. This is not true. This is not true. Fine. But the answer would not be option D. So answer would not be option D. Answer would be option C in this case. So this is the second case of either or. Fine. What is the condition like? I'll just write it again. I'll just put it here. All A, remember this, nothing to remember basically, these are complementary statements. This is statement 1, all A are B, and the second one would be, just a minute, some A are not B. So it's exactly the same type. So if you get two statements like this, all A are B is one, and the second one is some A are not B. If you get two statements like this and both are false simultaneously, अगर आपको दो ऐसे स्टेटमेंट मिलते हैं और दोनों एक साथ में गलत हैं, दोनों एक साथ में गलत हैं, तो उस केस में अगर आपके आंसर ऑप्शंस के अंदर either 1 और 2 जैसा ऑप्शन है तो वो आंसर हो जाएगा. If you get two such statements and both are false simultaneously like they are in this case, and you have an option which says either or, so that becomes your answer. So answer in this case would be option C and not D. Please remember this. This is extremely critical. Fine. I'll just tell you one last thing about this thing, this either or. Just listen to me. I'll just explain it here. This is again one of the contentious issues, but not something that I'm not sure of. There are some things in which even I'm not sure what you should mark because that's like such stupid silly issues. But this is something in which I do not have a problem. Some people keep asking me something like this. I'm just writing you something to you. Some A are B and 2 some A are not B. If something like this is given to you, fine, let's say these are two conclusions, that are given to you, some A are B and some A are not B, and you come to know that this is not following and this is not following, fine. So the question becomes, what should you mark the answer as? Is it an either or case? Fine. Many people say that it's an either or case. No, it's not an either or case. The reason is very simple. Look at the dictionary definition of either. Fine. खुद से check करो. Don't believe what I'm saying. Fine. Just check it yourself. Either means one of the two. Either always means one of the two. Either this condition or this condition. When you are doing this, when you are saying that it is an either or case, some and some not, the problem is that if I draw a diagram like this, let's say this is my exact diagram, this is A and this is B. Now both are being followed simultaneously. Some A are B, yes, this is the overlap. Some A are not B, yes, this is also true. Look at this region. So this is the region that satisfies 2 and this is the region, this region satisfies 1. Either or does not mean that. Either or, what is either or? Either or is either this is true or that is true. So the two cases that I gave you earlier would follow either or because they are disjoint. I mean, if one is happening, 2 is not happening. If 2 is happening, 1 is not happening. Whereas this third case, because many people say there are 3 cases of either or, this third case does not follow that condition. The problem with this third case is that if you get a diagram like this, the one that I have drawn here, this follows or this shows that some A are B and this part shows that some A are not B. Both are being followed simultaneously. If both follow simultaneously, it's not an either or condition. That's why I believe that this is not an either or case. I hope I have made myself clear. So this is first of the many contentious issues. मतलब ये उसमें बहुत विवाद वाले बहुत सारे मुद्दे हैं सिलोजिज्म्स में, ये उसमें से पहला है, बट इसके बारे में मेरे को कोई डाउट नहीं है, ये आइदर और का केस नहीं है. अगर आपको कोई ऐसा एग्जाम पता है जिसमें वो एग्जाम बॉडी आपको इसको आइदर और मानने पे मार्क्स देती है तो आप उसके साथ जाइएगा. अगर आपको कुछ नहीं पता है तो आप इसके साथ जाइएगा. मेरे को इसमें 100% विश्वास है कि इसका ठीक आंसर है. All right, I am moving forward now. This is again a contentious area that people had problems with. Fine. So this is your last question, I think, in fact, for the day. Just do it. That's your question. Just give me the answer. I'll just wind this up then. All right, can we do it? All right, to all of you who are asking different questions like रीस्टेटमेंट का क्या होगा, रिवर्स सिलोजिज्म का क्या होगा, आप लोगों ने मेरी FB पे पोस्ट नहीं पढ़ी है शायद. मैंने फेसबुक पे कल एक पोस्ट डाला था, उसके अंदर मैंने बहुत क्लियरली मेंशन किया था आज हम सारे फंडामेंटल्स करेंगे. मेरे हिसाब से जितना हमने किया है दिस इज इनफ टू गेट 5 आउट ऑफ 5. बट लास्ट टाइम इन IBPS आपको 2 क्वेश्चंस मिले थे रिवर्स वाले, हम कल वो करेंगे और जितने भी इसके अंदर मिथ्स, मिसकंसेप्शंस, डाउट्स, क्लैरिफिकेशंस, क्वेश्चंस हैं वो सब हम कल करेंगे. तो मैंने इसको 2 पार्ट में ब्रेक किया है. आज के सेशन के बाद में आई थिंक एवरीबडी शुड बी एलिजिबल टू गेट 5 आउट ऑफ 5 इफ यू गेट दीज कॉन्सेप्ट्स. कल हम सिर्फ वो पार्ट करेंगे जिसमें इश्यूज हैं. तो अभी मेरे को बार बार उसके लिए आप प्रॉड मत करिए, मैं आज वो नहीं डिस्कस करूंगा. I'll repeat this in English. What I'm saying is that this session is divided into 2 parts. I had already discussed this in our FB post yesterday that today would be basics. Basics does not mean just basics. This is enough to get 5 out of 5. Believe me, this is enough. Tomorrow I'll just discuss reverse syllogism, those 2 questions that came in the IBPS exam last year, some variations of them and some contentious issues like रीस्टेटमेंट फॉलो होता है कि नहीं होता है, पॉसिबिलिटी फॉलो होती है कि नहीं होती है एंड थिंग्स लाइक दैट. सो देर आर टेंस आई डोंट नो डजन्स ऑफ इश्यूज लाइक दैट. If there is an issue, I announced it yesterday as well. Please put it on that particular thread where I announced the sessions for syllogism. There is a thread on our FB group in which I announced these 2 sessions. So just put it there on that thread. I will tonight just read all the posts on that thread, would try to address all your issues there. I hope all of you are listening to me. Fine. So if you put something there and it's an issue, if it's a genuine issue, I'll discuss it tomorrow. I'll tell you my take on it. Then you're free to decide whatever you want to do. Fine. So just put it there. I'll discuss it tomorrow. I'll wind this up, this session today after this last question. All right. Now this is for you. Let's do it quickly now. Some houses are schools. So you draw houses and then you draw schools. All schools are not bags. This is fine. This is bags now. So schools, bags, they are disjoint. We draw it like this. All right, move forward. These are pencils. No bags are pencils. Then you again make a symbol like this, which shows that bags and pencils are disjoint. Wonderful. Fine. And then this 4th one. All pencils are pens. Now, if you look at this, this is, I mean, again, quite simple. Look at the first one. All schools being pencils is a possibility. Fine. Yes. How do you do it? Very quickly. This is slightly different. That's why I'm just giving it 30 seconds. If you look at this, I can put it like this. Fine. Is it creating any problem for me? No. What is the condition? It says all schools being pencils is a possibility. So I can put this whole part inside pencils very easily. Can I? Yes, I can. Look at this. So if I put it inside, all schools being pencils is a possibility is followed. So this thing follows, this conclusion 1 follows here, right? Move forward. So come back to the original Venn diagram now. Now look at conclusion 2 now. Some pencils are houses. If you look at this, some pencils are houses. Is it true? No. So this does not follow. This is a positive affirmative statement. So you look at the Venn diagram and decide. So it does not follow. Look at number 3. All pens being bags is a possibility. Again not possible. यहाँ पर देखो ये pen है. These are pens. So can all pens be put inside bags? No. Why? Because pens and pencils have an overlap. So bags and pencils are disjoint. So that part of pens, that is pencils, cannot overlap with bags. So that's why it's not possible. So again, it's not possible. And look at the fourth one. No pencils are houses. Fine. If you look at this, it says no pencils are houses. But is it true? No. It can be negated. How it can be negated? Look at this. So in this, if you look here, no pencils or houses has been negated. I can see here that they can overlap like this. So that's how even this one is eliminated. So these are your final answer options here. Now if you look at these answer options, fine, you feel tempted to mark this one. This only one follows as the answer, and this is a mistake that people do a lot of times. You do it in a hurry because you are in a hurry to do it in 30, 40, 50 seconds. You mark A as the answer. But just be very careful. There are two statements here that follow over either or condition. Fine. So the answer here would be not A, but this one. Look at this. Some pencils are houses. What is this form? This is some ARB. And no pencils are houses. What is this form? This is no ARB. So statement conclusion 2 and conclusion 4. These two conclusions here. This one and this one. They are complementary. Fine. They make a pair. If they make a pair, the answer would be only one and either 2 or 4. So the answer would be option C. So just be very careful with this. This is not difficult. Fine. The important part here is that you do not miss this. So whenever there is an either or that's visible to you in the answer options, the way it is here, fine, just be very careful with these two sets of statements as I just told you. एक ये वाला और एक दूसरा वाला. उसके अलावा किसी भी और चीज में you do not need to worry. आसानी से हो जाएगा. But this is something in which even when you know this, you can get it wrong in a hurry. So just be very careful with this. That's the only thing that I wanted to tell you here. So this is it. I'll just come back on screen now for a minute. Alright, so this was the session today. I do not know how many of you enjoyed it, how many of you did not enjoy it because you knew it earlier. As far as I am concerned, this is the only thing. I mean, this is syllogisms for you. There is nothing else. Watch this again if you do not understand this. Even if you do not understand a very small word, I'll still suggest watching it again. If you get this, you'll get 5 solid marks if it appears in the exam. Tomorrow's session would be just doubts, clarifications, myths, misconceptions, and reverse syllogism. Reverse syllogism is nothing, it's a stupid topic. People have made a hype out of it. I mean, that's absolutely nothing. You do not need a Venn diagram in most of the questions in reverse syllogism. I'll discuss 3-4 questions in reverse syllogism first tomorrow and then all your doubts. On our FP group, there is a thread in which I have, I'm discussing all these doubts. So if you have a doubt in any of these things, let's finish this forever this time. I mean, I do not want any more doubts saying ye kyun nahi hota, wo kyun nahi hota. If you've got any doubt, just put it in the thread. I'll take it up tomorrow. That's the agenda for tomorrow's session. That's why I'm doing 2 sessions on this. So this would be it for today. I hope this was meaningful for you. This was fruitful for you. If you do not understand, please watch it again. Alright, I'll call it a day. Wish you a very happy learning phase. Thank you. Thanks for your patience.